So we're going to talk about Ego app builders. There's a couple. So you got some choices. One is to, when you're dealing with, I guess, web app builder or even on your own, and you're in the JavaScript area, it's the 3 versus the 4. Okay. And 3 is older, and that 4 is newer. It can do 3D. It has a lot of promises built into it. It has lots of web workers, works really well as well in 4, right? So the big split from 3 to 4 is 2D versus 3D in that. So if you're doing any scene stuff, definitely going to be in the 4 JavaScript API in that. And then it's web app builder versus experience builder. This choice about 2D, 3D usually only comes up in the web app builder. I think experience builder is solely based on the 4. So with a web app builder based one, you can go WAB, you can go WAB developer. So there's a developer version of web app builder. Easerai has a set of widgets that you can choose to use or not use. What if you want to develop a new widget that doesn't exist yet? That's what web app builder developer is about. Okay, but they also have configurable apps. That thing that is shunned right now, it's at the bottom of the list, and they're hoping you don't scroll down to it. There's a whole bunch of app templates that people have made ahead of time using the web app builder technology, right? And the idea is you just grab one of these app templates, change a few settings, and voila, you're done. Low code, no code, right? There's the experience builder based set of, I guess, apps. You have experience builder. There's also an experience builder developer edition, just so you know it's built on React in that. But the experience builder is about, again, like web app builder, right? There's a suite of widgets, web controls that Easerai has curated for you, but it's a limited set. And if you need to do something that's not on that list, then you need the developer edition to build your own web control in that. The instance apps are associated with Experience Builder. Okay, they're like the configurable apps for Web App Builder, but they're Experience Builder base, React technology. We should probably also mention Calcite, the cascading style sheet library from Easerai in that. So you've got some choices in that. Some of them are made for you, right? 2D, 3D. Where you have to make this choice between 2D and 3D is in Web App Builder. And when you make it, what are you doing? You're signing a deal with the 3.x devil or the 4.x devil. You just have to choose which devil you dance with in that. But my advice is, if you are able to make this choice, right, go with the Experience Builder technology in that. Oh, also the new story maps. It's on this, like I said, it's 2nd generation now as well. They've been doing the web stuff for a long time. I mentioned that video, so if you haven't watched it, carve out some time and watch it, where I go over the change arc and you'll notice that they got into the website really early, and they've been in there for multiple generations, creating products that you can use outright or use to build your custom application. So what you can do now is pause this video lecture and watch the demo on Instant Apps. What you can do now is pause this video lecture and watch the demo on Experience Builder. What you can do now is pause this video lecture and watch the demo on Web App Builder. So what I'm going to do now is talk about the evolution of JavaScript. So we said 2 core things. Cloud, so we kind of covered off that all the way up to platform level. Now we'll talk about the modern, web modern development, WMD, and that. So we're going to talk a little bit about JavaScript's evolution. And so the evolution, I have a not so quick overview. And I talk about JavaScript, where we were and where we are now. So although I use it in other courses, I think it fits in here really well, because if we're going to talk about web modern development, like where have we been? You're going to see, if you can get lost in YouTube, go down a lot of rabbit holes, and you're going to see a lot of different styles of writing JavaScript code. But if we were to update it for 2022, 2023, how would people honestly be writing JavaScript code if there was no legacy issues? If you have legacy issues, and you're going to trend for early 1997, 1998, maybe early 2000 and that. But without any legacy, if you could start with a clean slate, where would you start? Okay. And so what you can do is watch that video in the playlist and then come back to this video lecture. Welcome back. Right. So some of the key highlights, right, from that video would be JSON, just the concept of JSON, which happened early. And then the JSON function or object showing up in the browser. It means that all browsers can do JSON. They can all stringify it or parse it. So take a JSON object, turn it into a string, stringify. Take that stringified object and turn it back into a JavaScript object. And so when you're talking to a REST service, ArcGIS services, GeoJSON, it's going to come to you as the stringified version, and then you got to parse it back into an actual JavaScript object. A lot of this stuff is based on XML HTTP requests, which came, I guess when you look at that span, earlier in JavaScript history. I mean, it's called XML HTTP requests because JSON wasn't a thing at the time. So it was all XML. It's why SOAP XML web services exist, because at the time that was the standard, right? And so the XML that we would see today would be GML, but XML is still kicking around. Scalable vector graphics like SVG, that's all XML based. We can do symbology with that and markers. When you were talking to some of these web services that were SOAP XML based, you'd use a WSDL file, Web Service Description Language file, which was XML based. That would told you, well, these are the types of requests that are on the system, and these are the types of objects you need to create, proxy objects on your side to talk to the service, and that as well. There's also the stuff around require, CommonJS, AMD, asynchronous loading, in that Node.js impact, how JavaScript used to be locked in the browser. So someone just sat there and stared at it and said, you can take that V8 engine in Chrome, basically turn it into an interpreter like Python, and you could be doing JavaScript, well, almost anywhere. The focus at the time was server. So a server-side implementation, like PHP is a server-side language, we can do JavaScript in the back end. But then it was like, well, if it's an interpreter, then it can run anywhere. And that means it's already running on the desktop. It's already running on Mac. It's already running on Windows because it's in Chrome. So that means you could build desktop applications in that. And that's, spawns the Electron framework in that. Promises, right? It's a technique that I've shown in lab in demos where you can asynchronously get data and it will wait. And we can then chain it, then, and catch any errors if they occur. And then that import statement. What amazes me, and this is the ECMAScript. Actually, it's the ECMAScript module system. I will have to flip the M and the S and that. But that import word showed up, mid-range, 2/3 of the way through. It's been there a while, but you don't see people taking advantage of it till last year or so. Because I think they built, why would be a question. They built up so much code and so many libraries that use require or use the AMD or CommonJS way of doing modules or importing, that they're like, do we really want to rewrite all that code just to have this import word? But once the browsers had it and they could do the importing, it opens up this whole new world that we see with the bundlers. Well, not so much the bundlers, but more Vite and Snowpack in that. Okay, bundlers are in there because how do you all of these? This is the problem with Node. Like when you do that npm install, you get hundreds of folders, thousands of files, and you can't fire that at the browser. It can't handle that many requests. And so then the bundlers try to wrap it all up as one JavaScript file, which is easy. Okay, I'm just asking for one file. It can be a big file, but it's a lot easier on the browser. And how many requests, asynchronous requests, it can actually make to go get all these JavaScript files. There's no way the browser can go get 10,000 JavaScript files, right? And I'm not being hyperbolic or off my rocker on this. If you do a Node Express app and you look at the files and folders that get generated, it's almost scary. But the bundlers basically, take all those folders and files and wrap it up into one file. And if it's a good bundler, it'll tree shake it and knock out. It'll say, look, you're technically not using this code, so we're not going to put it in the final solution or the final app in that. And so, so the tree shakes, knocks out all the code. Transpiling is about, okay, this browser is slightly funky, or it doesn't know how to do polyfills, or not polyfills, but it needs polyfills because we'll have the right JavaScript code to do this functionality because it doesn't technically exist in this version of the browser, and that sort of thing. And that's what transpiling is trying to solve in that. And then today I've demoed this in lab a little bit. It's a bad way if you're in a regular JavaScript file. It's okay, I think, in my mind, if you're in a JavaScript module, that the async await. But the async await is kind of doing what a promise does, in all honesty, in that. So it's a different style of doing the promise. Like we did XML HTTP requests, and then people are like, okay, that's crazy. Let's do promises. And then people are like, I don't like promise. That's a weird word. Async await makes sense to me, and that sort of thing. So it's just the evolution over time. But where you end up, what products you're using. The thing about bundlers, if we go back up one, they seem to be associated with certain technology stacks and stuff like that. I'm pretty sure, where was it? Yeah, OpenLayers uses Parcel and that. And so sometimes you're switching bundlers because the particular product you're using uses a particular one, and all the samples are based on that as well. So lots of highlights in that evolution. The language has been around a while, so it's accumulated some stuff. It's changed some stuff over time, but you see that in different languages. And what you want is, okay, if I'm going to start today, what's the cleanest, tersest way I can write this code so that you stay sane as a developer. And so you wouldn't use everything. You would pick, I like promises, or I like async await. I like, I'm going to stick with ECMAScript module system. I'm not going to use require in AMD and CommonJS. I'm going to say if the browser can't do it natively, then I'm not doing it. That sort of thing. And again, the changes in the databases, right? Oracle and WebDB, MySQL, Postgres, doing lots of JSON. MongoDB only does JSON and stuff like that. So it's very interesting to see the changes on the databases as well. As in all honesty, probably trying to stay relevant. They don't, Oracle doesn't want to lose any market share to Mongo, and neither does Postgres, and that. So they'll make JSON work in the database, and most of them have done a really good job at it. Right, ESBuild is kind of interesting in that one of the interesting things is that if you use a library that's written in CommonJS format or require format or AMD format, is that they can convert it on the fly to an ECMA module system module, which is really nice. Which means what it means is because people will look at it, would you have read all that code? And so someone wrote the code that would rewrite the code for you on the fly. And it only has to do this once when it pulls the library from the CDN or from the site and puts it onto your laptop where you're doing active development. It's just got to pull that library once, translate it, done. After that, it's a new version of that library in the EMS format that the browser can handle. But these things allow for some interesting middleware to all of a sudden pop up. I've seen talks that middleware is dead, but obviously no, you can't get rid of middleware. You can bury it, but you can't get rid of it in that. And so it allows for these interesting products like PG FeatureServe, PG TileServe, which are tied strictly to Postgres PostGIS, but flip those formats into, in case of FeatureServe, GeoJSON, and in terms of PG TileServe, Mapbox vector tiles. All stuff that you need as a JS person for your mapping clients like Leaflet, OpenLayers, and the Easerai JavaScript API. So all good stuff. And so we'll talk a little bit about Node's impact. Again, this is uh, from the diagram change arc in that or the video, but I'm just going to go over it again, right? So Node.js, what is it? JavaScript interpreter, right? If I, it's a different way. I don't know if anyone it has has ever said it like that, because it was never said like that to me. But I did a video series. It's on YouTube. It's called Node First Steps. And so how to get Node set up on home and how to do some basic JavaScript stuff. But I did it in a style like I do my Python labs. Almost some of the same labs I do or demos I do in the lecture there, but I did in JavaScript. And that's where it really hit home for me, is that, hey, this is just like the Python interpreter. The way I'm using it right now, absolutely no difference. And this is why it was able to be used in the backend server, like Python server pages, on the desktop, like Python is in Arc Pro, right? And it actually, because Google makes sure that the Chrome engine is working for Mac and working for Windows and working for Linux, then the interpreter is cross-platform for you. So it opens up this whole new world. So JavaScript gets out of the browser by going to the back end, but once it got to the back end, then it could go to the desktop and it can go mobile. It can go to all these different places. It's completely got freed and that sort of thing. So that subtle thing, like, hey, I could use the V8 engine as an interpreter, and because the person was building web apps, and I can do JavaScript on the front end, and I can do JavaScript on the back end, and I'm not switching languages all the time. But that epiphany, right, to do that, then shot JavaScript everywhere because of Node and that. So like I said, analogous to the Python terminal based on the V8 engine from Chrome. It's got a few other things like an event loop. So a lot of asynchronous stuff happening, a very asynchronous nature of how Node runs. And you could, if you wanted to, when you query a database in the backend using Node, as you pull out one row at a time, shoot it to the browser, right? A lot of people like to get all the rows and then take all the rows and shoot it to the browser. But you could go one row at a time, shoot it to the browser, shoot it to the browser, that sort of thing, and have it slide in, right? There's a few more libs that handle DNS, which is like IP addresses and names, like resolving www.bcit.ca, what's the IP address, encryption for HTTPS, a little bit about handling files back on the server, and a few more libraries too. But it didn't take much to put around the V8 engine to have like a complete solution that could do web stuff and desktop, right? So JavaScript, not in the browser anymore, huge thing. Desktop, phone, server side, okay? And that. So it's big that little epiphany, hey, I could use the V8 engine as an interpreter and do backend scripting in JavaScript. All of a sudden opened up all these other areas too. Desktop, phone, server side, right? But boom. Oh, keep going back. And desktop is just not Windows. It's Linux, Mac. Like, we're talking serious level of cross-platform, right? So Windows, Linux, Mac, Android, iOS, okay? And whatever your server might be, usually Linux, some flavor, maybe it's BSD, that sort of thing. So it really opened up this, okay, JavaScript now technically can be anywhere, and it's up to developers to see if they want to try it and build stuff. So there's NPM, big part of Node Package Manager, right? npsjs.com. And so we used that. I showed you how to set up a development server at home, HTTP server. We used NPM to install that. All the code. You'll be shocked if you go look at the number of folders and files I got laid down for that particular HTTP server in that. But basically, you can go grab all this pre-built software that's tested by lots of people and kept up to date and just use parts of it. And that's what we did for the dev server in that. But it does lay down a tremendous amount of folders and files. It's absolutely scary. But it's all built into Node in that. The Electron framework, this is a very interesting thing. This is where you can build cross-platform desktop applications using Node and therefore JavaScript. Your interface would be done in Cascade style sheets and HTML, right? And so those are the language you would use for your user interface design. But if you're a web developer, all of a sudden now you can be a desktop developer because you can take those CSS skills, those HTML5 skills, and apply them to building desktop applications in that. And so there are some there are some very interesting desktop applications out there in that. So, and the thing you're building is technically within inside the Chrome browser, just so you know, and that thing. So we're taking the Chrome browser and basically stripping off some of the outside stuff, like the tabbing and stuff, and using that window to render all the HTML and Cascade style sheets. So no joke. VS Code, which is a tool you probably see me use in demo videos where I was like writing HTML, that tool, VS Code, is an Electron framework application. And so that is written in JavaScript in the back end. You can go in VS Code, I think on the about, I think if you go about the product, you'll get the version, but you also see the version of Node that it's running, the version of the V8 engine it's using, and that as well. And so VS Code, right, sometimes I think it's slow, but what it can do, it's a pretty sophisticated IDE. It absolutely caught on fire. It shows up in all these interesting places because of its cross-platform nature. And that it does help me get stuff done. So there's some nice stuff it has built into the editor in that. But that is an Electron Framework app, desktop app, Electron Framework, technically HTML cascading style sheets, JavaScript, JSON, right? All being processed by the Chrome V8 engine in the background.